This video is going to go through the topic of grounding, which I really like, and I find that students mess this up perhaps more than any other topic in this chapter. So, grounding introduces a new circuit, a symbol, this one. It has these three little lines, maybe you'll see it 2, maybe you'll see it 4, and notice that unlike everything else, it ends. There's one connection here and then it goes to nothing. What is here? Well, literally the ground, or perhaps a metal connection that's going to take you to the ground. So that's the ground symbol. What is it actually doing? Well, it is setting the point of 0 volts. What that means is here we get to say that this is V equals 0 volts. Up till now, we've only been talking about potential differences, right? So an EMF is a potential difference. But once I say that this is 0 volts, I get to say that this is 10 volts here. I get to say that as it goes around and I have a delta V of 4, it's 6 volts there. So this is just a way of setting an absolute, right? So I can say I have a brother that is 13 years younger than me. Okay, I've told you the difference between our ages, but you don't actually know how old either of us are unless I tell you how old one of us is. So this is just like saying, hey, my brother is 43, and then I can say, oh yeah, and I'm 10 years younger than him, right? You can start going through and using differences to get absolute values. That's what we use grounding for, and that's it. There are other contexts in electronics that we use it for, typically safety, and honestly, none of those matter for this class. So thinking about having a ground for this class simply means a point where you are defining to be 0 volts. If you continue on and do more electronics in your future, you'll see it used in slightly more complicated ways, but right now you just have to have this basic down. So something really important is that no current flows to ground. So whatever current you have flowing this way is the current you have flowing here. No current flows there. So that's kind of like saying it isn't really there. It does not change the behavior of the circuit in any way. This is kind of like a Gaussian surface in that it's just kind of imaginary and it allows us to do math. So that's important. Another aspect of this is that we can ground different points on the same circuit. Now, you should only have one ground point per circuit. That's true. But I have the same circuit on the left and the right. Notice that one's a little higher than the other, but you would see that they're still the same circuit. Similarly, they have their ground in different places. So what that means is that the absolute value of the potential is different, but the differences are still the same. So on the left circuit, it's the ground point that I showed you before. So we have 0 volts here, we go across the 10 volt battery, so we get to 10 volts. We then drop across this resistor and go from 10 to 6, so that's a delta V equals 4. We then go across this and we have delta V equals 6. And now here we've chosen to ground between these two resistors. Again, in no way does that change the behavior of our circuit. Makes no difference whatsoever. But now we can label our absolute value of potential, so we label our voltage. And notice that when we go from 0 down here, we still have a delta V equals 6, and now we're at negative 6 volts. That's okay. That's no problem whatsoever. Don't let that freak you out. That's just like being in the basement. You can choose to talk about the height that a ball is at compared to the floor under your feet, or compared to the ground surface outside. No difference. The ball still falls the same way if you drop it. So this point over here is 6 volts because you have an ideal wire in between. Then when we go across the 10 volt battery, we go from negative 6 to 4. And again, 4 down to 0 is a delta V of 4. Again, I should put units on all of these, I'm sorry. So again, you see we've grounded different places, so the absolute value of voltage is different. However, the differences in voltages are all the same. Remember that the differences in voltage, or the potential difference, is what tells you about current flow, and so the potential difference tells you about behavior of your circuit. Defining a 0 point is just convenient for math. So if I'm analyzing a more complicated circuit, I will typically ground a point of it so that I can start assigning some fixed values of potential. So if I'm doing a calculation of a complicated circuit, I might not explicitly use Kirchhoff's laws the way that me and the book have shown you to. I'll actually use grounding as kind of a shortcut. So you're being shown this right now so that you know how to interpret it, but the biggest takeaway is that you can ground wherever you want, 1 point per circuit, and it's simply a mathematical tool right now. It's not something that changes any aspect of your circuit's behavior.